Cross-canceling. What is it, and why does it work? By Jeff Simpson. You may have seen fraction problems like this one, 3/5 times 5/7, where the teacher crosses out some numbers and then writes in some other numbers, and you wondered, why did they do that? And you thought, how do they know what to do? It is called cross-canceling, and this video will show you what it means and how to do it. Some students watching this video are still a little shaky with basic multiplying and dividing, so the video also contains a helpful review of those ideas. Cross-canceling is based on several ideas that are put together. The first idea has to do with multiplying. For example, if someone paid you $5 on Monday, $5 on Tuesday, $5 on Wednesday, how many times did they pay you? Well, they paid you 3 times, Monday, Tuesday, Wednesday. How much money did they pay you altogether? $15, because 3 times 5 equals 15. But what if they paid you $5 just 2 times, Monday, Tuesday? Well, then they would have paid you $10 altogether, because 2 times 5 is 10. What if they paid you $5 just 1 time? Well, then they would have paid you $5, because 1 times 5 is 5. What if they paid you $20 1 time? They would have paid you $20, because 1 times 20 is 20. Or what if they paid you $10 1 time? They would have paid you $10, because 1 times 10 is 10. Here is a review of the last 3 multiplication problems we just did. 1 times 5, 5. 1 times 20 equals 20. 1 times 10 equals 10. Based on what you have just noticed about multiplying times 1, solve these problems. 1 times 3, 1 times 9, and so on. They're easy to solve because it's the same number. 1 times 3 is, guess what? 3. 1 times 9 is 9. And it works the same with fractions. Up on the top right, you see 1 times 1/2 is 1/2. The first idea behind cross-canceling is that if a number is multiplied by 1, the answer is the same number. Or in other words, multiplying a number by 1 does not change that number. Here are some examples of the fact that multiplying a number by 1 does not change that number. Works with fractions too. 1 times 3/4 is still just 3/4. 1 times 5/8 equals 5/8, and so on. The second idea behind cross-canceling has something to do with dividing. For example, a mom told her 5 kids, "Here are $5. Divide the money so that each of you gets an equal share." 5 kids, $5. How much money did each kid get? Each kid got $1, because $5 divided by 5 kids equals $1 each. There are 3 ways to write 5 divided by 5 is 1. There's one of them with a division box. Here's another one. 5 divided by 5 equals 1. And you can also put a 5 over a 5. A number over a number means dividing. 5 divided by 5 equals 1. 3 different ways of writing it. They all mean the same thing. Here's another example. A dad told his 4 kids, "Here are $4. Divide the money so that you each get an equal share." How much money did each kid get? $1, because 4 divided by 4 is 1. There are 3 ways to write 4 divided by 4 is 1. Here they are. One more example. A grandma told her 3 grandchildren, "Here are $3. Divide the money so that each of you gets an equal share." How much money did each kid get? $1, because 3 divided by 3 is 1. And there are 3 ways to write 3 divided by 3 is 1, same as the other ones. Here they are. Here is a review of the last 3 division problems. 5 divided by 5 is 1, and you can write it those 2 ways if you want. 4 divided by 4 is 1, so on. Based on what you have noticed about dividing a number by itself, solve these problems. 9 divided by 9, 6 divided by 6, and so on. These are easy to solve because the answer is always 1. The second idea behind cross-canceling is that if a number is divided by itself, like 4 divided by 4, the answer is always 1. Here are some more examples of the fact that dividing a number by itself always equals 1. $10 divided by 10 kids equals 1. 2 divided by 2 equals 1. And you can look at the other examples. The third idea behind cross-canceling has something to do with equal value. Look at the pictures. At the top you see a box with $4, another box with 4, another box. That's 3 boxes. Each has 4. 3 times 4 is 12. The next picture you got 2, 2, 2, 2. 6 groups of 2. Also makes 12 altogether. 3 times 4 is 12. 6 times 2 is 12. They both equal 12. So down at the bottom we can see, well, 3 times 4 equals 6 times 2. 3 times 4 equals 6 times 2. They both mean the same thing. You can replace the 12 down here at the bottom of the picture with something of equal value. You see the first one has 12 over 12, which means 12 divided by 12 equals 1. Or you can rewrite it 12 divided by 2 times 6, which is 12, equals 1. Looks a little fancier, still means the same thing. The third idea behind cross-canceling is that you can replace any number with something of equal value. Here's some examples of replacing a number with something of equal value. The first fraction problem you see is 18 divided by 18 equals 1. That's either fraction or division. 18 divided by 2 times 9, well, 2 times 9 is 18, so it really means 18 divided by 18. And you can see the other examples, all of them showing that dividing a number by itself, or something equal to it, always equals 1. Dividing a number by itself always equals 1, and you can replace any number with something of equal value. You can see those examples. Stop the video if you'd like. Here is a review of the first 2 big ideas behind cross-canceling. A number divided by itself equals 1. A number multiplied by 1 equals itself. Now, put the 2 ideas together. You see the arrows pointing in the middle of the picture with a 2 over 2, 2 divided by 2, also called 2 halves. Well, that's just a fancy way of writing 1, isn't it? 1 times 3/4 equals 3/4. Another way to look at it, 2 halves, or 2 over 2, 2 divided by 2, is a creative way of writing 1. 1 times 3/4 equals 3/4, because a number multiplied by 1 doesn't change. So you see at the bottom of the picture, 2 halves times 3/4 equals 3/4. It's actually the same as 1 times 3/4 equals 3/4. Here are several examples of the two ideas put together. Notice the blue over the red, same number, divided by itself, so it equals 1. You can stop and look at these if you like. The fourth idea behind cross-canceling has something to do with multiplying again. For example, Pat's dad commutes 10 miles to work every morning. He's going from home, drives 10 miles, and he gets to work. Commute means to drive to work or to drive home from work. And he commutes 10 miles back home every evening. Commuting, driving to work or driving back home from work. Commuting to work, the distance is 10 miles. Commuting home, the distance is also 10 miles. When commuting, the distance is the same, whichever direction you go. Multiplying is like commuting. 2 times 5 equals 10, but also 5 times 2 equals 10. If you change the order of the numbers, like 3 times 5 or 5 times 3, the answer is the same, no matter which way you go. This order-changing quality of multiplication has a special name. It's called the commutative property. The fourth idea behind cross-canceling is the commutative property. When you change the order in multiplying two numbers, the answer, also called the product, does not change. Remember the second big idea, a number divided by itself equals 1, and the third big idea, you can replace a number with something of equal value. Here we can see some examples. 12 divided by 12, same thing as 4 times 3 divided by 4 times 3. Either way you look at it, it's 1. Here are some different ways of saying the same thing. First example, 12 divided by 12 equals 1, or 3 times 4 divided by 3 times 4 equals 1, 4 times 3 divided by 4 times 3 equals 1, or you can get creative and switch the numbers around. Bottom left, 3 times 4 divided by 4 times 3 still equals 1. So, a number divided by itself is 1. And you mix this with the commutative property down at the bottom left, 3 times 4 divided by 4 times 3. It's really the same number, 12 divided by 12. Now, the fifth idea behind cross-canceling has something to do with rearranging. Now, this is true. 3 times 4 divided by 3 times 4 is the same as 12 divided by 12. Same thing as 1. And this is also true. 3/3, some people will call that 3 over 3, I call it 3/3, times 4/4 equals 12/12 equals 1, because you still multiply the two top numbers and the bottom times the bottom. These are both true. 3/3 times 4/4 equals 1. 3 times 4 divided by 3 times 4 equals 1. And they mean the same thing. This one equals that one. You can rearrange multiplied fractions by putting them together. See the two examples? On the left, it's this fraction and that fraction. On the right, you make one bar and have the numbers over the top and the numbers over the bottom. You're rewriting or rearranging by putting them together. And you can also rearrange multiplied fractions by breaking them apart. You can put them together like this, and this. And you can break them apart, like this and this. Rearrange, use the commutative property, and rearrange. Let's look at an example. You see the fraction being multiplied down there, 3/4 times 4/7. Now, let's rearrange them by putting them together. We can see 3 times 4 now on the top, 4 times 7 on the bottom. Now, this gets interesting. Rearrange the top numbers by changing the order. Instead of 3 times 4, now we'll write 4 times 3. And now we'll rearrange them again by breaking them apart. And we've changed what we started with to 4 over 4, 4/4 times 3/7, just by rearranging using the commutative property and rearranging again. The fifth idea behind cross-canceling is that you can rearrange multiplied fractions. Here's a list of the 5 big ideas behind cross-canceling. A number divided by itself equals 1. A number multiplied by 1 equals itself. You can replace a number with something of equal value. There's the commutative property and rearranging. Step by step, here is how the big ideas are put together to solve a problem like this one, 2/3 times 3/5. Rearrange the multiplied fractions by putting them together. Then rewrite the top fraction by using the commutative property. So 2 times 3 turns into 3 times 2. Rearrange the multiplied fractions by breaking them apart. Cross out the 3's and replace them with 1, because any number divided by itself equals 1. So 3/3 turns into 1. Multiply the 2/5 by 1, and any number times itself, times 1 is itself. 1 times 2/5 is 2/5. Here is another problem solved the long way, step by step, 5/7 times 7/8. You rearrange by putting the numbers together, both on the top and the bottom. Then you use the commutative property on the top numbers by switching the order. Rearrange them again by breaking them apart. Now you've got 7 over 7, 7/7. So you cross out the 7's and replace them with 1's because 7 divided by 7 equals 1. Or you can cross out the 7's with a giant 1 if you want to, because 7 divided by 7 is the same thing as 1. Then multiply the 5/8 by 1. And the number is still 5/8, and you're done. Now, if you had not done all the rearranging and rewriting, the final answer would look like this. Now, you'll see the short way to solve the same problem, 5/7 times 7/8. Cross out the 7's, replace the 7's with 1's, multiply the numerators, that's the numbers on top, 5 times 1, you get 5. Multiply the denominators, they're on the bottom, 1 times 8, 8, and you're done. 5/8 is the answer. Here's the idea behind the short way. You see the 7 on the bottom and the 7 over there on the top. Why bother with all that rearranging? Just cross out the 7's right where they are. It is called cross-canceling because you're canceling or crossing out the 7's that are across from each other. In this video, you learned 5 big ideas behind cross-canceling. In part 2, you will learn more about why we do this and see more advanced ways of doing cross-canceling. You can get more practice with cross-canceling in Chapter 5 of my Fractions book, which is available online at masterylearningsystems.com. Please share these ideas with other people that can benefit from them. And thanks for watching.